And this is where a lot of students will make mistakes, because when I read the equation I realised, haha, half N2, half O2, so in my reactants I must half the total entropy. So now let me get my really posh calculator up. Where's my really posh calculator? There you are. So let's have a look. So I'm going to do the brackets first. 192.2. I'm going to add 205.3, and that gives me 397.5, but I'm going to divide that by 2. It gives me 198.75. So what I've got is 198.75. I need to take that away from 211.1. Going back to my real cool calculator. I'm actually going to clear it. I'm going to put it all into my calculator. 211 to 11.1. I think that's a minus sign. Minus. My eyes are going 198.75. So we've got a 12.35 entropy change. Now we have to be very careful. See, we've got to pay attention to our units. This here, delta F is in kilojoules, well, entropy is in joules. So what we got here, delta G is 0 equal to 90.4 times 1,000. So that'll be 90,400 minus T. I'll put into brackets here 12.35. Now, what I'm going to do is I'm going to rearrange this to find T, and I'm not going to do it as an A-level maths student. I'm going to do it and I'm going to pretend that I've already done GCSE maths. So this is plus positive 90,400. I'm going to move that to the side. So that'll give me minus 90,400 is equal to minus T times 12.35. But you see, I don't like minuses, so I can do the whole thing, and talking A-level talk, I can times by minus 1, or I just switch them both to positives. Equals T 12.35. But I don't want 12.35 T's, I want 1. So what I do is I divide both sides by 12.35. This cancels out that, leaving T. And this should give me, let's get my fancy calculator up. Let's clear that. 90,400 divided by 12.35 equals. There we go. You see from the big screen, I've got a crazy number, so I'm going to round it up. I've got what? 7,319.8. 7,319.8 Kelvin. And that is a 5 marker. I have jammed it up, but I hope that makes kind of sense in terms of what was going on in my brain. Okay. Alright, a student had an idea to earn money by carrying out the following reaction. Graphite to diamond. Use data from the table on page 4 to calculate values for delta H and delta S for this reaction. Use these values to explain why this reaction is not feasible under standard pressure at any temperature. Okay. Now, if it's not feasible at any temperature, that will mean delta G is always bigger than 0, no matter what happens. So if I look at the formula, delta G is equal to delta H minus T delta S. Now, you'd think the bigger this quantity gets here, at some point, no matter how big delta H is, this take away a positive number, the point will get big enough for it to become 0. But the thing is, if we suddenly had delta H being positive, then we could somehow make minus T delta S positive. You'd always have a number bigger than 0. And the way to think about it is if we take minus T and delta S, so we've got minus T times delta S, that's what this means. Then as soon as I have this as a negative, as soon as this is negative, a negative number, then you've got a negative here multiplied by a negative here, you're going to get a positive. Your number's always going to be bigger than 0. So what I'm expecting is, I don't really care about delta H, but I'm expecting it to be positive. I'm expecting it, because if it's negative, well, it's going to be a spontaneous reaction at some point, but I'm expecting it to be positive. I also expect delta S to be negative. So I'm expecting this one to be positive and this one, delta S, to be negative. Alright? So let's get back. I'm just going to pause it because I'm going to bring in both questions. So let's just put this on pause so you can see all the data, the table next to it. Okay, so what I've done is I've brought it, copied and pasted the question here. Just bear with me a tick. Okay, so as I said previously, what I was expecting and what we're expecting, let's get back to the right page, it does help, is delta H. Now, delta H, the enthalpy of formation of diamond, and we'll do it in blue, is here. Graphite is 0, so the calculation for delta H is the sum of the products minus the sum of the reactants. The products is nice, it's 1.9, the reactants is nice, it's 0, so delta H here is a positive 1.9. So let's have a look at delta S. Again, sum of the delta S for the products